All right, we are on the half hour, so we're going to go ahead and get started. Thank you all for joining today's Ask the Experts session, which is actually Ask the Experts today because we have two of them, and we're very excited about that. So with me today, I have Josh Green from Databricks and Fredrik Jansson from Avassa, and they'll be talking about model management at the edge and how to close the loop of AI models in distributed edge environments. So the agenda for today is quite significant, so we're going to keep up, and I'm not going to take up too much time here and actually hand over to the experts, but we're going to start off with an introduction from Josh and Databricks, move on to what we mean by closed loop ML and MLOps using Databricks. And then we have a bunch of cool demos lined up, both from Databricks and from Avassa. And we'll finish off with demonstrating how the loop is actually closed from cloud to edge and back. So with that, I'm gonna hand over to Josh.
Yes, it's a pleasure to be here with you today. And so I'll get started. So today we're going to be talking about several things. The first thing I thought I'd start off with is a bit of an introduction to MLOps and also to Databricks as well. So first question we can answer is, well, what is MLOps? And it's a lot of things, but if we're going to summarize it in a few words, essentially it's a set of processes and automation that reinforce those processes to help us to manage all the data and code and models that we use within machine learning and AI. And the goal of doing these things, or the goal of this process, is to actually improve the performance, the stability, and also the efficiency of ML, so we can actually trust the models that we're using and deploy them in a more effective way. And so it really is a combination of data ops, DevOps, and model ops all coming together to actually make something which is very, very powerful. Now, Databricks, to answer the second question, is what is Databricks? Well, Databricks is a lot of different things. And today, unfortunately, we don't have time to talk about everything. So instead, we're going to focus on three different areas. The first technology which we're going to use a lot is Delta Lake, which is our underlying data storage format. It's a table format which enables us to store the data in a very efficient way that we're going to be using to train our models. The next thing is MLflow. So MLflow is a model registry. It's a means by which we can track different experiments, the whole life cycle of models, all the way from that first experimentation phase through to deployment, and then also through the retraining process as well. And then, of course, we have those DevOps aspects of things. So, tracking our code, following the life cycle of the code and the infrastructure which we're actually deploying, and making sure that we have a repeatable way of deploying models. And so, this is kind of a perspective on the Databricks ecosystem, which is a very data-centric ML platform. So I hope that you've come to this session today, with the interest in MLOps, and I think I'd like to kind of justify the interest by kind of telling you, why should we care about this? Well, the first goal that we have in MLOps is to try and reduce risk, right? And there's kind of two main areas here. There's the technical risk, so the chance that our model will perform poorly or our infrastructure won't be able to stand up to the requirements that we have on it, and this will end up impacting our operations. There's also the compliance risk. So I'm sure many of you are working in areas which are regulated, and we need to make sure that we can actually adhere to those regulations, and in some cases also report to those. And even if you don't have those kind of regulations, there are probably some corporate policies you need to be able to follow as well. This is really important when doing machine learning. But another area which we can support also is actually the efficiency side of things. So being able to improve the efficiency long term. And the long term part is really key here, because sometimes when we start on the MLOps journey, it can seem a bit daunting. Like, there's so many things I need to think about, there's so many different processes I need to follow. But actually, the payoff comes later on. Like, once we have a repeatable way of deploying and streamlining our models, getting into production, we can really speed up those next steps, or those follow-up models. And also, we have this means to kind of catch errors before they can have an impact. And finally, most importantly, is avoiding these manual processes, which can actually be error-prone as well, and often cause big issues. So hopefully that's convinced you that MLOps is an important endeavor. And it's not just something for data scientists. Oftentimes we can think, oh, it's just we could leave the data scientists to do this. In this diagram, you can see there's multiple steps along the journey, and some parts of this are handled by data scientists, others ML engineers getting involved, even business stakeholders are there in terms of validating the model and deploying it. And today we're going to be looking at steps number 3, a little bit of step number 4, but then mostly 5 and 6 are going to be our focus today along this journey. And as we follow this journey, there's some guiding principles that we want to bear in mind, always when we're doing ML ops. The first one is to stay data centric. We're data people, hopefully, in this session today, and so this should be second nature to us, but it's also worth bearing in mind. But being data centric, we can also sometimes lose focus on the business goals. At the end of the day, we're working in a business, and we want to make sure that we're actually achieving the goals that we have, rather than just using technology for the sake of technology. One of the key aspects of MLOps is the reusability, which helps us achieve the efficiency. And we want to do this in a modular way. So there's always going to be some common pieces that we can reuse. And that's definitely one of the things we're going to be showing today, is how we can actually reuse these common aspects. And that's something, a common goal we have within MLOps. And then the last piece is, obviously we need to have automation, but this automation should be driven by processes. So we actually have, a clear path from experimentation through to production. So diving a bit more in details on some of the things we're going to look at. So lakehouse monitoring is one of the tools that we have for actually monitoring models once we get them into production. And this allows us to actually calculate metrics, to measure model drift, and even just define our own custom metrics as well, to evaluate our models when they're in production. And today we're going to see how we can actually retrieve these metrics back from the edge and use them to evaluate our models once they're deployed. And also the nice thing is we can automatically generate some dashboards to view these for you. The other side of things is going to be the inference tables. So inference tables are essentially tables which are generated to show the inputs and outputs of your model and how the model behaved. And this essentially allows us to obviously monitor our predictions. We can understand, given a certain input, what our model is doing. And this is kind of useful if we're curious, but it really helps us when we're trying to debug issues and also track model drift using lakehouse monitoring. But most of all, and most importantly, really, I think, is the ability to then use this for further retraining. So next time we train our model, we now have even more data to feed it because we actually have data from the field. So putting it all together, really closing the loop here, we actually have this ability to take our model, do the training, go through the evaluation deployment, serve that model. And today we're going to be using Avassa to serve that model in this edge environment, and then bring this inference data back through inference tables to then do that retraining. So this should helpfully visualize what we're trying to achieve today. Now, with that said, let's jump over to Databricks Notebook and have a look at how we might train a model. So I'm not going to spend a long time talking about this one, but let's imagine that we actually had a model. And in this case, I'm going to be using the AutoML feature of Databricks to train the model. We've done that, and maybe we'll go on a bit more detail on that later on. But we've registered that model into MLflow, and now we have an experiment. So this experiment, if we jump over there, actually has a bunch of different metrics that are defined. So in MLflow, in the AutoML side of things, we automatically generate a lot of different runs. And we can also see the different metrics that have been gathered for this. And so in this case, actually, we decided to use the F1 score as our validation metric to decide what the best model is. And so if we pick a model at random, let's take this one, we can actually go further into detail about the metrics that were defined for that model and all the different parameters that were fed in for that particular training run and evaluation. And then once we have that, we can actually register this as a model, and it will show up in Unity Catalog. And the nice thing with Unity Catalog is we have all the data that was used to train this model. We have all the, and then also have the model itself all tracked in the same place. And once I have this model, I now have an artifact which I can do a lot of different things with. I could, for example, if I wanted to, deploy this and run it as a REST endpoint, but that might not be relevant in this case. Maybe I want to deploy it to the edge. So I can actually build a Docker container, and I can then pass this over to Fredrik, and he can take that further and deploy it for me. So over to you.
Thank you. Thank you. So while I get ready, can you say a bit about MLOps? Can I run that locally in my basement, or Is it always cloud hosted?
Well, yeah, the nice thing is that within Databricks, we're using MLflow. And so MLflow is an open source tool from the start. So it means that, yeah, if you're using Databricks, it's fantastic. It's fully integrated with the platform. But if you happen to want to run it in other places, that's completely fine. So yeah, as you say, you could run it on your own laptop, but you could also run it even hosted in other places as well. I think even AWS has a managed version of MLflow if you wanted to do that. So yeah.
Cool, awesome, thank you. So Josh has built models in MLflow. We have taken those models and we have actually taken the Docker containers and pushed them to Docker Hub. So I'll show you in a moment what that looks like in the Avassa system. And now the idea is we want to take that model, including the serving engine, and run that in multiple places at the edge. And then as we use the model, we utilize it for whatever it's for, we're going to collect inference data and send that back using S3 buckets to Databricks. And I'm going to double click just one here and tell you exactly what we've done. So we actually built, so the output from MLflow is actually this model server, including the model, which is a Docker container in itself, which means it's very simple to bring it up in Avassa. Then we wrote some Python code that actually intercepts all the requests to the model server, and it will forward the request, it will get the response back. And by capturing that, we can actually send that inference data. So request and response and some other metadata back to Databricks through an AWS S3 bucket. And Josh will double click on this later, exactly what you can do with that data. So now I'm going to go into the demo and show you what this actually looks like. So just quickly, this is the application. I have two containers in here. One is the actual model tagged with v1, so I'll show you an update later. And then we have the Python code, which is just sitting in front. It's exposing a port here, 18080, which I will interact with to access the model. So let's go here into my Jupyter notebook. So this is one of the instances I'm running in a site called Stockholm Cluster. So it's actually this one we're going to be talking to. And it's nothing fancy, but I want to show you. I do a request with some input data, and I get a prediction back from the model serving engine with a result. So now let's suppose we have done some training. We have actually evolved that model. So we have a version 2 that we want to roll out to all our edge sites. So that would mean a v2 tag up here. I'm gonna set the correct model version in the metadata, and then I'm gonna update this to version 2.0. So let's do an update here. And I'm gonna go to, yeah, and I actually set this to auto update, but I'm gonna use Stockholm Cluster as a canary site. So now you can see that it's actually updated. So we are now running version 2.0. Again, this is pretty cool if you think about it. By packaging the models in containers, it becomes really easy to roll out new versions and get them into production in a matter of minutes in many cases. And just to prove that I'm running a different version now, version 2.0, if I now go back into my Jupyter and send the same request again, you can see that I get a different answer back. So this is definitely another version of that model. So now I'm going to hand it back to Josh, and he will show you what happens when I've been running my requests here, and see what that looks like on his end.
All right. Yes. So I'll quickly bring back. So I've created a virtual table on top of the S3 bucket, which Fredrik had created for me. So this is so in my Unity catalog meta store, I can see I have this requests raw table. So you might be wondering, how did that appear? Or how did that come about? Well, I can go in here and see the lineage graph, and actually I can see here's this external location, which is S3 bucket. It's throwing into my request raw table, and I can see downstream also that I have my process requests, which I've used. So let's find out more about where this came from. And if I click on pipelines, I can see that I have my ingestion pipeline over here. So here's my pipeline, which is actually reading in the data. And essentially, I can rerun this pipeline. I can refresh the data and pull in more information. And also then I can process this. So if I quickly show you the source code here of this pipeline, you can see we have our schema for our data. You can see that I'm defining this request table on top of the S3 bucket here. And then I'm converting this information into a format which is then similar to the inference table that we have with the Databricks. So if you're running the model in Databricks, you will generate the inference table. If you're running the model in Avassa, then this will also generate the model for you. And so if we jump out here, we can see that we've had some records coming in the last run, which was actually reloading this. So by doing this, we can actually then define on the request table, we can actually define quality metrics to be able to monitor model drift and things like that. So just before the session, I created this monitor, which is based on our requests table, and it's a classification or prediction type. And so we've specified, okay, my prediction column is this one, my model ID column is this one, so I can track the different versions over time. And then I can actually go and view a dashboard, which is automatically generated to see, okay, how's my model doing? In this case, it's a very simple model, so there's not very much exciting things to see here. But if we have a more complex model, we can actually start to look at what's the most common predicted class, or what's the F1 score, and track that over time. So in this way, we have the ability to very easily monitor our model both in the cloud and at the edge in the same way. It's completely the same experience, regardless of whether you're using the model in the cloud or on the edge. So that's all from me, and yeah, I'll hand back from there.
Thank you so much, Josh and Fredrik, for those demos and for your insights. I encourage everyone that has a question for either Josh or Fredrik to keep posting them in the chat, and I'll start off with the first one that I received, and it's for the both of you, but let's start with Josh. So what is, from the customer side, what is the key driving forces or the value that your customers is looking to accomplish using your technology?
Sure, yeah. So I think obviously, working in the cloud is really convenient and really simple because you have a lot of resources. It's really easy to get access to different GPUs or CPUs for actually training your models, and it's easy to collaborate. So that's really nice. But unfortunately, in reality, the world is a bit more complicated than that. And oftentimes, either for performance issues or for network challenges, we need to have models running at the edge. And in that case, it's not possible to use the cloud in that sense. And so I've seen a lot of different customers finding workarounds, finding different solutions to doing this. But I think the real value here is actually having this end-to-end process, right? As we say, closing the loop and being able to not just push models to the edge and kind of wave goodbye and never hear from them again, but actually deploy the models, monitor them, and then reuse that information back again to train them and enhance the quality for the future iterations as well. So I think that's really, really valuable for a lot of our customers who, would love to be in the cloud all the time, but that's not practical, unfortunately.
I hear that. And what about you, Fredrik? Based on what Josh is saying, do you see AI being a key driving force for Avassa as well?
Yeah, absolutely. I mean, when I talk to customers and potential customers, AI is definitely on the table in many discussions, and there is a lot of curiosity about what ML AI can do for them, and I think it's super interesting, and cool area to be able to be a small part of.
So another question for Fredrik. The Avassa platform, is it supporting any other types of containers than AI models? That's a very good question.
Yeah, so absolutely. So as long as it's a container, we can take that container to your edge and run it and monitor it and so forth. So it's not a platform for models only or AI ML only. It's a general platform.
Awesome. Another question here. Does Agassi see any issue with latency? Is that a question for, you're going to have to help me out here. Is it for Josh, maybe?
I think maybe that was an autocorrect error for Avassa.
Is it Avassa? Because it says Agassi in the autocorrect as well. Maybe it's for Avassa. Yeah, that makes sense. Avassa. Thank you, Anders, and thank you, Josh. So, question for Fredrik then.
Any issues with latency? I mean, latency is one of the reasons pushing models to the edge. Latency, and I would say large amounts of data. It's simply too costly to send all that data to the cloud to do an inference and get a result back. So I hope that answers the question. Latency and is certainly one of the drivers for the edge, I would say.
Anything you want to add to that, Josh?
Yeah, I can second that. I would say also, yeah, the latency question is, especially if you have devices deployed in areas with not good network connectivity, whether that's in a factory somewhere or they're deployed in the field. It's very common for latency to be a challenge, right? So you don't have, this is one of the reasons why customers can't use the cloud in every instance, because if you have a poor network link and you're having to kind of use a model to detect issues, for example, you don't want to have to wait for the link to come back up again to figure out that like the bearings in your machine have gone and you probably should have stopped it 10 minutes ago. So yeah, I think definitely that's one of the reasons why it makes sense to have the models at the edge.
Awesome, thank you. Another question here. What type of AI models are supported, with a follow-up question, if there are any custom containers specifically for NVIDIA hardware in the Jansson family?
Yeah, so within Databricks, we don't have any limitations on what models you can do. So it's a completely open platform. Obviously within MLflow, we have some kind of pre-baked model flavors. What that means is, for things like GBM or for different types of deep learning models, we those kind of, or scikit-learn even for basic things, those kind of things are already integrated very closely with MLflow. So what you'll see is that rather than having to log the metrics yourself, we'll automatically extract the metrics from the model. So that can make things a bit faster. But you can use any model you like, right? And especially for using NVIDIA acceleration, that's also completely supported. So if you need GPUs when training, we're able to provide GPU instances. At the end of the day, we're just using the instance types provided by the underlying cloud provider. So if you're using AWS or Azure or GCP, we can use all of the instance types that they have available, whether that's AMD GPUs or whether it's NVIDIA GPUs or others. And then, of course, when you're actually deploying that at the edge, if you have NVIDIA GPUs available, then amazing, yeah, and that can also work, I assume. But I'll let you discuss that, Fredrik, if you want anything to add there. Yeah,
sure. Yes, so we do have NVIDIA support and also Intel GPU support at the edge for actually executing the models at the edge.
Awesome, thank you both. So we have an additional question here, which is also a really good question. Can Databricks and or Avassa be managed in a GitHub pipeline, for example, through GitHub Action?
Yes, excellent question. And yeah, so that's actually how a lot of the deployments are driven, right? So you have your CI/CD process defined in like Azure DevOps or GitHub Pipelines or another tool for actually just orchestrating that. And so everything which we have in Databricks is orchestrated through REST API, which you can either use directly, you can use it through a CLI, you can also even use it through Terraform. Really, that's the best way to do it. But all those kind of deployments can be will be triggered from GitHub Actions, for example.
Yeah, and I'll add to that. We have the same story basically there. We have REST APIs and the CLIs, so it's actually pretty easy to integrate the deployment and all of that into a CI/CD pipeline, and that is, as a matter of fact, what we recommend our customers to do for all their containers that they're going to run at the edge, including ML models, of course.
Awesome, thank you. So we are moving towards the hour. If there are any more questions, we'll stick around for just a minute or so. And otherwise, I'm gonna bring up a slide where you have some contact details for Fredrik. I'll make sure to share a few for Josh as well. And if you want to reach out afterwards, I'm sure you're both happy to answer questions also after this session.
Absolutely.
Yes.
So thank you all for coming, and make sure to stay tuned for our Ask the Expert session that's going to return later in September this year. And thank you, Josh, for coming. We're so happy to have you.
Thanks. It was a great pleasure. Thank you.
Yeah, thank you so much for taking the time. Really good.